Aeronautics department.
Okay, yeah, so this proposal is for a different department, and the purpose is to replace a flash X-ray system from the 1960s with something a little bit more up-to-date that a broader base of students can use. Just a quick introduction to flash X-ray. It's a specialized type of X-ray diagnostic that uses an extremely high-powered pulse for a very short period of time. Now this pulse originates from a tungsten-lined vacuum tube that's installed inside an X-ray head, which collimates the beam to only emit from the front of the head. And that's placed in front of the object you want to X-ray or the path of that object. This is then triggered with a 150 kilovolts, and that fires the X-ray pulse, which then is captured by a digital phosphorus plate, which can then be scanned by a laser at the UW Medical Center. That gives you an extremely high-resolution X-ray image. It's a lot like photography, and I've included some pictures of what those images look like in my PowerPoint that was distributed to everyone. This is a diagnostic for non-human use in a lab environment, and this X-ray machine is actually not designed to be used on humans, so you're not allowed to do that. And it's suited for transient phenomena like weld inspection, experiments involving motion and ballistics. The machine contains no radioactive material, and the dose, if you were to stand in front of the emitter tube, would be 400 millirotogens of radiation per pulse. But this is actually quite small, considering that on average you're exposed to 200 millirotogens per year from background sources. However, I mean, no one's going to do that, right? And then there's also a graph of the penetration of the X-ray into aluminum, depending on the distance of the X-ray head from the aluminum, because the beam actually expands slightly. Okay, so our current hardware is from the 1960s, and the X-ray tubes are past their recommended lifetime, so there's only a certain number of shots you can get out of these before they degrade and fall apart. And the hardware is rather obscure and difficult to interface with modern data acquisition systems. So this means that the machine really doesn't get used a whole lot, although we did use it for the sounding rocket program, and we have an X-ray further into the PowerPoint that shows a fuel grain that was X-rayed while it was being fired inside a rocket engine. The proposed replacement hardware is a up-to-date version of this system built by L3 Pulse Sciences, and it's a complete single-channel 150 kV flash X-ray. It's about $60,000. We're also proposing 4 replacement X-ray tubes for the lifetime of the machine, and 2 digital phosphor X-ray plates and cassettes, as well as a cleaning kit. Okay, there's also an image of the rocket fuel grain. We took an X-ray of that. It's basically a paraffin wax cylinder right before ignition of a rocket engine, and then 3 seconds after. And then by overlaying the 2 images, we could actually determine exactly how much wax had burned in that 3-second time period. And that was a very useful piece of data that we got there. There's a couple more images here showing golf balls and stuff being hit by bullets. This is a projectile from Carl Nolan's experiment, the RAM accelerator. It's traveling at 1,700 meters per second, and you have just a picture like it's just standing still right there. So in summary, as far as student access, students will be able to check this machine out and move it to a different lab or a different department for whatever diagnostics they need to run, because the machine is on wheels and it's portable with 1 or 2 people. Users will be briefed on and required to follow, the standard radiation safety guidelines, and we have some lead shielding and other equipment available. The machine's easy to use and quite reliable, and it's controlled remotely over an Ethernet computer interface, so you can trigger it from a completely different room in a building. As far as departmental support and responsibility, the primary contact actually quit yesterday, so Carl Nolan will be the new primary contact and handle checkout and maintenance and safety training for anyone who wants to use it. As far as cost-benefit, the total requested is $75,000. I believe that's justified because with minor upkeep, the machine could last for many decades, as the previous one was actually from the 1960s. As far as direct users, I don't think there will be a whole lot of those, but you have to kind of think of this in terms of the number of people that will benefit from the data generated. And I believe that number is far greater, maybe a couple hundred people when you consider that it may be used on some of these large projects like the Tram Accelerator and the Z-Axle Pinch and the HIT program. As far as scholarship, I believe this proposal has very strong scholarship potential because it's a very unique technology that's really typically only found in like a national lab. And it will find many long-term uses in different research programs. It's also essential for hypervelocity, material impact, shape charge studies, and even kind of less exciting things like weld inspection or inspection of engines. And the flash X-ray tubes and the phosphor plates will really increase the image resolution that's available. So there's a couple more backup slides showing different images from a detonation, an exploding bullet, lead filling in a mold, inspection of a radiator, and some door panels. So that's it.
Thank you. Do you have any questions for the author? All right, thank you.
Okay, I just wanted to point out in terms of partial funding options, if there is not enough money for this proposal, it would be possible to just partially fund just the replacement X-ray tubes and the phosphor plates. That would get the current system that we have going from the old X-ray, and then we could try again later for the full complete replacement.
Sure.